everyone. So in our previous video we saw the definitions and the derivation of expression for work, and we learned that work is a scalar quantity and work is defined as the dot product or the scalar product of force and displacement vectors. So in this video we'll focus on how to connect the definitions of work and energy, and we'll also derive the work energy theorem to denote the connection between work and energy. So let's consider this example here. So we have an object of mass m, and the object is initially stationary, which is denoted by its initial velocity being 0. And now to this stationary object I apply a force F newtons, and because of this F newtons the object accelerates and it moves. Let's consider the displacement of the object to be d meters, and after d meters suppose its final velocity is v subscript f. Now what is the work done by this force to move the object from a state where initial velocity was 0 to a state where final velocity is v subscript f? So we'll derive an expression for this. So from first principles we know that work is nothing but force times distance. Now how do we take it from here? So we need to basically find out how much this distance was and plug it into this expression. So from our equations of motion we know that the final velocity at this point Vf and the initial velocity and the distance are related by the expression Vf square is Vi square plus 2 times the acceleration because of this force. So let's call that A times the distance. So Vf square is Vi square plus twice the acceleration times the distance. That would be the expression for the final velocity. So from this we can plug in Vi as 0. So 0 plus 2 times acceleration times the distance. So what would distance be from this? Distance would be Vf square by 2 times A. Now what would 2 times A times dB? So your force can be written as mass times acceleration times the displacement. So A into D can be written as Vf square by 2. So when we plug this into here we get work as m times Vf square by 2, which is nothing but half m Vf square. Now this is very interesting because the work done can be given in terms of just the mass and the final velocity. So as you can see, the work done is getting translated into a form of energy in this case. This is the expression for the energy due to motion. So this is also called kinetic energy. So essentially the work done by this force is getting converted into kinetic energy of this body. So work done is given as half times m times Vf square. So this is very interesting. So let's take an example to illustrate this. So suppose initially the body was at rest, Vi 0, and suppose after a distance d, let's say 5 meters, the body was having a velocity of 5 meters per second square. So this is all the information we have. And suppose the body was of mass 2 kg, then even without knowing the value of the force, we can calculate the work done. So work done would be half into 2 into Vf square. So that is phi square. So this would be 25 joules. So this is one of the most fundamental theorems in classical mechanics. So essentially the work done by any force can be given by the change in kinetic energy of the body as it moves from one point to another. And this result is commonly called the work energy theorem in kinematics. Thank you.